The Palm Pilot, one of the most useful and successful PDAs of the 1990s. It was almost like having a smartphone in your pocket, only before the invention of the smartphone, and without the phone bit built in. Except for the version that had a phone built in. Yes, I had one or two of them back then, and I've picked up one or two more since. So we're going to have a look at the history of the Palm Pilot, a number of the devices, and yes, we will get into the nerdy detail. But before we get into all that good stuff, I should say, this video is sponsored by PCBWay. Fine purveyor of printed circuit boards. Yes, you design a thing, you upload the files, and in exchange for money, they will send you back PCBs in the post. It's pretty much what you expect that kind of service to be. If you give them even more money, they'll put some components on the board for you. They'll even do 3D printing, CNC machining, and of course injection molding. They won't do knitwear though, they don't touch knitwear. So PCBWay for all your non-knitwear needs. Palm was originally founded in 1992. By Jeff Hawkins with the idea of writing software for a pre-existing PDA. Yes, Palm did not invent the PDA. Created by Tandy, known as the Zoomer, which itself was one of the first PDAs, and probably should have been more successful than it was, but given that it was based on x86 and cost a surprisingly large amount of money, it just didn't do as well as Tandy/Radio Shack had hoped for. But given that the platform didn't do quite well, Palm's PIM software that was designed to synchronize the PDA with other things out there, that did surprisingly alright. And Palm continued to develop their software to run on various HP devices, and of course the Apple Newton, a piece of hardware that is famous for being Apple's biggest failure at the time, and Apple's first foray into the whole mobile market thing long before they decided to do the iPhone, or in fact the iPod. But soon, Palm decided that they were going to create their own PDA, and this is where stuff gets interesting. Now, I should say, we have a little bit of corporate shenanigans going on at this point, because Palm gets purchased by US Robotics, the modem people, while they're developing their first PDA, and they do release it with US Robotics branding on it. But then US Robotics shortly afterwards gets bought by Freecom, and it becomes the Freecom Palm Pilot. IBM would also license this thing, and it would become a ThinkPad branded product as well. And then the founders would get annoyed, leave, and start their own company, Handspring, who would also make very suspiciously like a Palm Pilot device running Palm OS. But let's get back to the first two devices they put out there, the Palm Pilot 1000, 5000. Now, these devices both have everything that all the later Palm Pilots would feature. This is where we see the initial grain of their success. And while successful in their own terms, these are nowhere near as big as the later Palm Pilots that would come out. But weirdly, despite the fact that people kept calling them Palm Pilots pretty much all the way through their life, and still do now like I am, these are actually the last devices to feature the name Pilot in them, because they end up getting into a lawsuit with some pen company in 1998 and had to drop using the name Pilot in their products. So subsequent models would be known as the Palm 3 and the Palm 5, for example. Now, form-wise, you'll notice this thing is not that dissimilar to the form factor we have for modern smartphones now. And they came out in the era where the Nokia brick phone was kind of the standard mobile phone. We had other PDAs, but even the ones that have a similar form factor were usually considerably physically larger. The Newton is bigger than my hand, the Pilot is not. Cyan were there with their devices, but theirs was like a clamshell thing with a keyboard. It did actually comfortably sit in the palm of your hand. One big notable difference, though, is that you use a stylus to operate it rather than your finger. You can use your finger, but it's not very good at detecting where you intended to press with your finger, as fingers tend to be a lot wider than styluses, and the clickable elements being placed rather close together. This did create some unhelpful results. So you pretty much ended up having to use the stylus rather than just like the edge of the nail of your finger, until you inevitably lost the stylus, at which point then, yeah, you were doing the nail and finger thing until you got a new one. Did this happen to me? Yes, it did. In fact, I still have one I've not managed to replace the stylus for yet. So if anyone lost their Palm Pilot PDA but managed to somehow keep hold of the stylus, let me know. The other thing that's a bit different between these and how we use smartphones now is how you are meant to input text. Before Palm created the actual PDA itself and was just selling software, one of their projects was a system known as Graffiti, which allowed you to enter text by writing on a portion of the screen. Now, they're not the only people to have come up with this idea. Famously, the Apple Newton allowed you to do handwriting input. It was also famously rubbish at doing so, and took whatever you wrote and produced some characters from it. Graffiti as a system is different. It doesn't try to recognize natural handwriting, because that's quite difficult, particularly with 1990s equipment. Instead, they made you write in a particular style that it could recognize. So you wrote things one character at a time on a particular section of the, well, screen. This bit of screen isn't actually a screen as in it can't display anything, it's just a continuation of the service that the screen's on, and the touch sensitivity layer, and you draw on it one character at a time. Now, the shapes you produce are somewhat reminiscent of the characters themselves. I'll bring up a little display of all the shapes you have to put in to get an individual character out. And this in general, for example, worked a lot better than, say, the Apple Newton's approach to handwriting recognition. And it's something the user could get better at over time. So, once you'd got used to this, you could enter text reasonably quickly, still slower than an on-screen keyboard on a modern smartphone though. Now you might be wondering, why not just have an on-screen keyboard? That seems easier, right? And for me, yes it is. But the problem is the actual screen on these machines is pretty tiny and, relatively speaking, low resolution. So when you bring up the on-screen keyboard, it does kind of take up most of the screen. You can't really see the form you're filling your text into a lot of the time. The individual bits of screen segment for each key are also pretty tiny. Again, you're using the stylus, as there's a very small contact area, for each individual key, but that does sort of limit the speed at which you can input text. You also have a couple of mechanical switches that allow you to jump to the most important applications, and also around the area where you enter the text and the numbers, you also have a couple of software buttons as well that jump you back to the home screen where you can launch applications, bring up the menu bar in a given application. There's also a shortcut for the calculator and a shortcut for the search function as well, and a little power switch on the top. The next big thing about the Palm Pilot, apart from its physical form factor, was its excellent sync software. Now, you may not think this is the most important thing for a PDA, but PDAs could live or die based on the quality of the software you use to sync data with your machine, and also applications running on your machine. And Palm pretty much had this nailed from day one, because initially, this is what they were developing, this sync software just for other people's PDAs. Now, why it's so vital is because your PDA doesn't have a connection to anything else in the vast majority of cases. It doesn't do wireless, it doesn't have any mobile services built in. The way you get data in and out of this PDA is using the sync software. So you would connect your PDA to your PC using a serial port, and either with devices like the Palm 3, you'd connect a cable up to it, and it has this natty little flap to stop dust getting in there, or with the rechargeable models that had a built-in battery, you'd put them into a hot sync cradle that would not only charge your PDA but connect it up for sync purposes. Now, back in the day, the rechargeable models were the most sought after and more expensive ones. However, now if you'd like to try one, I'd take one of the models that takes the AAA batteries, as assuming the original owner has removed the AAA batteries, all you have to do is put some new ones in and your Palm Pilot is good to go. With the likes of the Palm 5 that has a battery built in, or the 5C, that lithium-ion cell has kind of rotted over the years, unless someone's been very good about keeping it charged. And replacing that cell, well, it is possible, you can still get cells for these things, but you weren't really meant to take a Palm 5 apart. It's kind of glued together. So taking it apart and replacing the battery involves a lot of quality time with a hairdryer. And the battery cell is of course glued to the back of the LCD panel. So if you don't get that glue pliable enough, what you do is shatter and break the LCD panel when you try and pull the battery off. Yeah, less than ideal, but it can be done. It's just a lot of faff compared to the Palm 3 where you just put a couple of AAA batteries in the thing. Same with most of the handspring models as well. Anyway, back to the sync software. There's a couple of things going on whenever you run the sync software, or perform a hot sync as it's otherwise known. The hot sync does a couple of things. Firstly, and probably most importantly, it backs up all the data on your PDA. Why is that so vital? Well, it comes down to this battery thing again. If the battery goes flat in your PDA, all your data just disappears. While flash storage technically exists at this point in time, it is horrendously expensive. So, your Palm Pilot doesn't have any. Instead, the data just lives in RAM, and as long as the batteries are not flat, that data stays in RAM. As soon as your batteries are flat, well, your data's gone. So, regularly syncing your Palm Pilot, pretty important. Now, you might think that's a pretty fatal flaw. Well, it was common across all of the PDAs as well. So, for example, the Apple Newton, it's got no flash memory either. Again, it just keeps stuff in RAM. It has a little coin cell battery to stop your RAM from dying while you're changing the massive array of batteries that power the thing. Some PDAs did have flash cards, so you could store some stuff on the flash card, but it didn't come with a flash card, and they cost quite a lot. So, for example, on this Sinclair device here, I can get little flash cartridges for the thing. Well, sort of flash, yeah. But they cost nearly the same amount as the device itself. Same with a number of Psion's offerings. Again, you could buy these flash cards, but boy did you pay for them. So the backup of all your applications and data with the Palm Pilot was pretty important. Again, it was just connect the cable or just slot it into the cradle and hit the sync button. And it would just back up all your data and the applications as well. And if your batteries had gone flat, well, it'd just write all your data and applications back onto the Palm Pilot. So assuming you synced fairly regularly, and most people did so they could make use of the Palm Pilot, the whole it just occasionally murdering your data thing wasn't as big a deal as you think it might be. Now the next thing with the sync software we'll come to is the conduits. Now the original software came with a number of them, but application vendors could write their own sync conduit for their application. And this is what would sync data that was in an application with the, say, calendar or email or whatever features on the Palm Pilot. Sometimes there would also be a special application for the Palm Pilot that would let you use data from the original, say, Windows, Mac or Linux application. Side note, you may have spotted I used the word Linux in a device that's from the 1990s, and incredibly, Palm support for Linux was brilliant. For some reason, the open source community really took to the Palm Pilot, so very early on we had full working hot sync for the Palm devices and integration with all our standard desktop, email and calendar clients. You could also use Linux as a development environment for the Palm as well, and that is how a lot of third-party app developers did their development work. Now this conduit approach is a little bit different to how other PDAs of the time were doing things. They did all ship with some form of synchronization software, but usually that software was limited. For example, want to sync your calendar? Well, it will sync it with the one application that came with your PDA. You might get lucky and it might support another thing, but typically you got a bundled suite of Windows or Mac apps that your PDA would sync with, but those apps are all kind of a bit rubbish. Whereas the conduit model, that supported a number of the default applications that you would want to use for that sort of thing. So for Windows users, Outlook, for example, to sync their calendar and contacts. But as Palm got popular relatively quickly, other applications soon started producing conduits too, or a third party would for it. So, if you're using GroupWise, for example, as your calendar and email system in your company, well, it's alright, there's a conduit that syncs with that. Same with Lotus Notes. Most of the big applications of the time, they had a conduit to sync with stuff, or a third party would make one. Now, that was the nice thing about the Palm ecosystem. All the APIs and standards, everything you would need to target with your own code if you're writing something for it, well, they were all available. There was no trying to hide away how it worked behind proprietary standards. Anyone could write apps, anyone could write a conduit. Even the whole hot sync thing itself, well, yeah, all the specs for that were published. So the likes of the Linux community could write their own hot sync tools, and boy and how did they write a lot of hot sync tools. Hot sync is also incidentally how you would get applications onto your PDA in the first place. Typically you just had a folder, you put the application file in there, and next time you sync, well, it'd get installed on your Palm Pilot. Now so far I've described all of this with you cabling the thing up, but there were a few other options. The Palm did support making a hot sync over a network. Now, I know before I stated that the original ones came just armed with a serial port, and that basically remained true for quite a while. The Palms 3 and 5, well, they got something called IRDA, which is essentially a serial port over infrared. Now, although this protocol seems to be more or less forgotten now, it was implemented in most portable devices of the time. So, your Nokia brick phone, well, that had IRDA. That's what that dark red plastic window was. Laptops pretty much came with IRDA as standard. As of course, so did other PDAs as well as the Palm Pilot. Heck, HP even started to make printers that had an IRDA feature on them. It was the wireless standard effectively of the time. If by wireless standard you essentially mean a serial port with the cable missing. So if you had a device with an IRDA port, yep, you could hot sync over that. But here's the really clever bit. If you had a mobile phone that had an IRDA port, which supported emulating being a modem, then you could dial up a dial-up ISP using your Palm Pilot and either a serial port cable to your mobile phone or via IRDA, get an IP address and then connect to your home machine over the internet and sync your data. Now, this is all before home broadband was particularly common and smartphones were a distant dream. In fact, for many, this is why people kept their dial-up internet accounts still active when they got home broadband, as you still needed to dial like it was a modem if you were using a mobile phone. And why this ran at a whole 9.6 baud, which is torturously slow, it did mean that at quite an expensive data rate, we did have a lot of the functionality that we would later see in smartphones, just by syncing over the internet with your home machine. You also could do some more interactive tasks. For example, there was a web browser service called AvantGo. The Palms 3 and 5, etc. were not capable of running an actual proper web browser. They didn't have either the RAM or the CPU for that. The way AvantGo worked was you installed a conduit on your machine that would connect to their servers and download a compressed, simplified version of a number of web pages. Your Palm Pilot would then sync those pages down to the Palm Pilot, and the AvantGo browser, not really a full browser, would display these compressed, simplified web pages. But it did mean on the go, you could browse the web, as you could change which pages were being synced. And if you clicked on a link, on the next sync, it would get your AvantGo conduit to go get that web page down, do the minify and compress, and sync it back into your Palm Pilot. Now, other PDAs would eventually get this conduit concept in their syncing software as well, but not before Palm had grabbed a significant market share, and others would maybe not be quite so open as the whole Palm thing was. I mean, this everything is an open standard with the APIs available is probably what helped the Linux community, that was still pretty small at the time as Linux was relatively new, really get such incredible support for the Palm. Later on, things would also get a little bit smoother for remote syncing, as Bluetooth add-ons would become available for the Palm 5, for example, like this little blue shield you can kind of click your Palm Pilot into, and that adds Bluetooth support, so you can then Bluetooth through your mobile phone, or to your computer. As IRDA, whilst fairly broadly supported, could also be somewhat unreliable. If you, for example, didn't line the devices up properly, well, being an infrared beam, yeah, it kind of missed the target and data would become unreliable. Or if you're in a room that was too bright or warm, the infrared from the sun effectively interfering with your communications. Later, once Palm made the shift to using ARM, well then Wi-Fi and Bluetooth would get built directly into the device. But at the time of Palm's heyday, around the time of the Palm 3, Palm 5, etc., Wi-Fi has yet to be invented, or at least in the form that you can use in your house. Right, let's get a look at how the hardware works. Now, I'm going to be talking about the devices from their heyday, so the original Palm Pilot, the Palm 3, the Palm 5, most of the devices from Handspring, rather than the later iterations that are based more around ARM. So the original Palm stuff is all based on a Motorola system on chip, a later version of the Motorola 68K. Yes, you're probably all familiar with that processor. It's the one that powered the Amiga, the Atari ST, the Apple Mac, well, at least before it wasn't, early Sun hardware, and a whole bunch of games consoles, including the Mega Drive. But by the mid to late 80s, the 68K was considered somewhat old hat. But as a processor for a mobile PDA, well, in this system on chip form, it was a pretty good choice, as embedded inside that IC is quite a few useful things. There's the actual 68K-ish core itself. We've got serial UARTs to run the serial port that you use to pot sync the thing, and also the IRDA port. It's got the memory hardware on there for doing the actual DRAM controller and refreshing memory. There are versions of it with 24-bit memory addressing, or at least the pins for that, it's always 32-bit addressing inside, or 32 pins for memory addressing. But most importantly, from Palm's point of view, it also has an LCD controller in there. That means there's not much they actually have to add to this design to make it a functioning machine. Pretty much everything they need is in the chip. Known as the Dragon Ball, we'd see this thing in a number of mobile computing devices, but also later on a lot of home appliances use that whole LCD controller in there. If you have a washing machine with a nice fancy LCD display from the, say, late 90s, yeah, it's probably one of these. The power draw from them is also not bad at all for what it is. It's not quite on a par with the ARM stuff, but when it's paused, it draws very little power at all, and most of the time, this PDA spends its life paused. And as you have to keep RAM alive with the battery, so you know it still has the content in it, it's pretty important that your CPU isn't burning any power when it's in its pause state, or very minimal power. Also, the instruction set for the M68K is very well understood by a lot of developers and, importantly, compilers, which means you can build some fairly optimized code for this machine with a relatively small memory footprint. Because for most of its life, the 68K was used in machines that by the mid-90s would have been considered fairly memory constrained, like a PDA, and very usefully for them, the compiler GCC, which was the standard compiler used on Linux and quite a lot of other Unix operating systems, was very good at targeting the 68K. So a version of that compiler is what Palm shipped as part of their SDK for application developers. Now, the screen is pretty limited by modern standards. We have 160 pixels by 160 pixels. And in the Palm 3, that's got 4 whole grayscales, and in the Palm 5, that's got 16 grayscales. By default, when you first power the device on, the screen isn't backlit. It just relies on the light reflecting from the environment around it, saves battery. But if you hold the power switch for a little bit, it does switch on the backlight, so you can use it in the dark. For such a limited display, though, it did hold up surprisingly well compared to any other PDA and was very usable. We would later on get a colour version of the Palm 5, the M505. I'll come to the 500 series a little later on. In terms of memory, there is not a lot. There is 2 whole megabytes of memory and 2 mega flash ROM for the operating system. Applications don't go in there apart from the ones built into the OS. Any applications you installed yourself, their install is in RAM. Same with the data for everything. Now, the first versions we have are the Pilot 1000 and 5000, and they are very similar each to the Palm 3. Only at this point we don't have the IRDA port. We then have the Palm 3, which is probably the biggest seller out of all of them that we're going to mention, and that is essentially very similar to the 1000 and 5000. It takes AAA batteries, but it does have the IRDA port. Then we have the Palm 5, which is the sleeker, slightly fancier looking version, with more grayscales on the screen, and its own built-in battery, so you don't have to keep buying AAAs to put in it, and it recharges it in the dock that it comes with, as opposed to just a cable that you plug in. We would also get the Palm 5X, which is a slightly souped up Palm 5. It's got 8 whole meg of memory. Ooh. And they also produce some souped up versions of the Palm 3, again with larger amounts of memory. You then get the Palm 100 series, which is the M100, the 105, the 125 and the 130. The 100 is your cheaper entry-level one, is basically the same spec as a Palm 3 with 2 whole meg of memory. The 105 that has 8 meg of memory. Ooh. Then there's the M125, which has still got the same 8 meg of memory, but a slightly faster processor, but you can put an SD card in this thing. Finally, we have flash storage. Huzzah! We then have the top of the line, the M130, which is our M125, but with a colour screen. We then have the 500 series, which look all more or less like a Palm 5. The cheapest one being the M500, which has 8 whole meg of memory to start with, and a 16 shades of grey grayscale screen. We get the M505, which is pretty much the same as the 500, only it's got colour, 16-bit colour. Ooh. And then as a follow-up to that, we'd have the M515, which is colour just like the 505, only now it's got 16 megabytes of memory. It's getting posh. Now, I have mentioned in passing a company called Handspring. Handspring was founded by the same people who founded Palm, as those original founders were apparently not happy with the way things were going under Freecom's ownership, so they went off to go start their own thing. Now, they still licensed Palm OS, so they were using the same operating system, they were based around the same Motorola Dragon Ball CPU, and their initial set of models were all known as the Visor, i.e. they had the Visor Deluxe, the Visor Solo, the Visor Platinum, the Visor Neo, the Visor Edge. They had a lot of machines with Visor in the title, and they were all pitched at the same sort of level as the Palm 3 and the Palm 5. The Solo, for example, had 2 meg of memory, everything else had 8 meg of memory, apart from the Pro that had 16. The initial range all had grayscale screens, apart from the Visor Prism, which had 16-bit colour. Ooh. Now, one of the nice innovations about the Handspring's Visor range was that it used USB rather than RS-232 for syncing, which was a lot more rapid, and also it had a little slot in it for hardware add-ons known as the Springboard. Now, there were some really good add-ons for this thing. So, for example, there was a Wi-Fi add-on, a digital camera, extra storage, GPS, an MP3 player, and, most importantly, a mobile phone add-on. Yes, this thing could become the world's first smartphone, although I don't know if it counts if it's a PDA with an add-on device. Now I'm going to pause talking about the hardware for a minute or two, because we've covered all the models that were there in the heyday of Palm, and instead I'm going to switch focus to looking at what it was like to develop some application software for these Motorola Dragon Ball based PDAs, before we get on to how the Palm system changed. The primary development language for the Palm Pilot was C, and also C++ if you felt like it. Technically, you could develop in any language that you could compile for Motorola 68K, and that you could build a version of Palm's SDK for. So we did eventually end up with toolsets in Pascal and other languages. But the one Palm supported and gave you the SDK and compiler for is C. Now, as I mentioned earlier, what they gave you for the C compiler was a version of GCC, an older version of GCC, that would build and target Motorola 68K code. There was also an emulator, so you could try your code out and see what it would look like on a Palm device, and also there was some form of screen/menu icon designer type tools. Now, I, like a lot of people developing for this thing, did all my development work on Linux, but these were also available for Windows and Mac. Now, in terms of programming it, you are doing most of your work in C, but there are lots of regular C features you can't just use on the Palm Pilot. Want to use printf? Well, yeah, that's not going to happen. It's C, but without some of the standard I/O libraries. You don't do file I/O in the same way as you would normally in C. Instead, you had Palm's SDK that you would target. Now, in order to understand why this is all the case, you have to understand how Palm's operating system works, in that it does not work like most modern operating systems. In fact, the whole operating system is kind of like one application, and what you're writing is plugins for it. In that every single app is sharing the same memory space. They can all overwrite on top of one another. There aren't multiple tasks or processes running on this operating system. The whole thing is one giant event loop, and your application essentially gets linked up to that main event loop. And if your app crashes, well, that's it. The whole operating system's gone with it, because there isn't really an OS. There's just one great big application with plugins, much like Windows 3.1 and 3.0, etc. And you may be thinking to yourself, why on earth did they do it this way? Well, some of the reasons come up from the underlying hardware. This Motorola Dragon Ball CPU, just like the 68K, does not have a memory management unit. So that means you cannot have an operating system kernel sat there controlling access in and out of RAM. One block of code has just the same set of privileges as another block of code. There's no virtual memory space allocated to each process that the kernel, using an MMU, translates into physical memory addressing. Now, there are other operating systems for 68K based machines that didn't have an MMU that could do some kind of multitasking. Applications were a little bit more separate from the operating system, like the Amiga and the Mac, for example. But when you're running off a battery, you really do have to do things in the most efficient way possible. So having lots of calls in and out of an operating system, using complex interrupts and libraries, or the CPU's exception handling for that's not a real instruction, well, that's all a tad power hungry compared to there is but one application effectively and not really an operating system to speak of as an approach. It's also somewhat more concise when it comes to memory usage as well, because remember that RAM has to be used for working memory that applications and software are using, as well as storage for the applications, i.e. storing the apps themselves, and also storing the data that your application produces. So keeping your memory footprint as small as you can, well, that's kind of useful, with the downside that one application can bring the whole system down. Now, admittedly, even in the preemptive and cooperative multitasking systems of the Amiga and the Apple, that can still happen, because there is no MMU, so one application can just overwrite another application or the operating system. But on the Palm, this really didn't seem to happen very often. And part of that is that the Palm SDK has some very nice features in it, which might be a little bit weird for the average C programmer. Now, there's things you'd be expecting in that SDK, like there's libraries, for example, for drawing stuff on the screen, so each application doesn't need to know how to do that, and there's common reusable widgets for things like, say, a menu bar. There's a particular way you have to have the main loop of your application running, so it gets events in for stuff that has happened, or you need to start, you need to stop, you need to make your data available because we're going to try and sync it, or search is happening. I'll come back to search later. But every application effectively gets past an event, it has to deal with that event, and it has to go back to sleep to allow the main event loop of the operating system to move on to the next application that might need to do something. Although most of the time you are only running one application at once, but there are some that could do some stuff in the background by hooking this event loop thing. Right, so let's get back to memory. Now, as you might guess, you have to be very careful with memory in a system where one application can overwrite each other, and also storage and memory are one and the same thing. As if you mess up, not only are you going to overwrite another application and
break it. You can also overwrite what is effectively its disk storage and destroy all the data in that application permanently. Now, this means we don't use the normal C feature for dynamically getting memory. There is no malloc, and there is no free. No, instead the operating system has something known as the memory manager, and you make a call to it to get a movable chunk of memory. That's right, when your application essentially does its equivalent of malloc, the function memHandleNew, it gets allocated a handle to a block of memory. This block of memory might move around in the memory map each time your application gets called to do something. It's not just a fixed address range in physical memory. Before you can use that memory, you actually have to lock it. So there's a function call you do that locks the memory using the handle you were returned, and that then gets you a pointer to where it is frozen in RAM so you can use it, and once you're done, you then unlock it, and when there's no locks open, the operating system can safely move that memory around. Now, this approach is very useful for stopping memory from getting quite fragmented. It's also pretty safe. You're also quite heavily encouraged to develop a lot of your code so that it works with this memory management system. However, occasionally you do need a non-movable block of memory for something, and Palm OS does have you covered for that. You do have the function called memPTRNew, which gets you a non-movable chunk of memory of a given size. And once you're done with this block of non-movable memory, we'll then use memPTRFree to free that memory back to the OS. You also have a similar function call for the movable memory blocks, memHandleFree, that lets you tell the memory manager that you're now done with the contents of this memory handle, and it can just reuse wherever it was keeping that in RAM. Right, let's get back to search for a moment or two. Now, Palm offers you a little search box where you can type in your query, hit go, and each application will provide a response of records that match in that given application. And the way that works is when you type your query into the search box, Palm OS is essentially passing control to a search function built into each application. So your application has to return its search queries quickly, even if it has no results that match. Because if your application searches slowly, everything searches slowly, as it's simply just calling each application in turn to get the answer. When the search system gets the results back from all the applications, it then produces its on-screen list, and when you tap on one of them, then it switches control to that application and fires an event at it for the given record that you selected. Your app is then responsible for displaying that particular record that matched the search, based on the event that it's just received. Now, there are some other features that Palm OS provides for us application developers. One of the big ones is the Database Manager and the File Manager. The Database Manager gives us a standard way of doing flat file databases for every application, which allows us to create records, etc., store, retrieve, query them. We have fairly simple C functions to access and use that, like dm create database. Yeah, it creates a database. Dm open database opens the database. I think you can probably guess what dm get record does, or dm find record by ID. Now, the useful thing about these databases is when we run a hot sync, because the database manager is in charge of them, it handles the synchronizing the records between those and your PC and vice versa. We also have a file manager that works a bit more like a conventional filing system, in that you have the call file open, file seek, file read, write, etc. And these are what you expect as a way of your application just streaming some data into a file. Now, when hot sync runs, nothing particularly clever happens with these. All that happens is that they get backed up, because the file manager does have the list of them. Palm OS does give us a number of features we'd expect from the operating system. As I mentioned earlier, we have the whole event system and the whole API for doing UI, but we also have libraries for dealing with serial communications, doing pop-ups and notifications, what to do in the event of a reboot, stuff related to accessing the clock, an infrared API for controlling that IRDA port that we mentioned earlier, and even a network library and an internet library, which has an interface not too dissimilar to the Unix socket interface, only there's some built-in support for the HTTP protocol as well, and we have a bunch of localization features as well. I should also probably mention the standard I/O library. Yeah, I kind of lied to you earlier when I was talking about you don't have standard file I/O and printf and stuff like that, because you kind of sort of do. This is not really how you're supposed to write Palm OS applications. In fact, things using this library are not standard Palm OS applications. They're what's known as a standard I/O application. You have to mark them as a separate type when they get installed onto your Palm Pilot. And when your application starts, it doesn't start in the normal way a Palm OS application would. No, it hits a function entitled SIO main and gives you the normal argc and argv stuff you'd expect in a Unix application. But in order for these things to run, you also need something known as a standard IO provider application, and that is a more Palm OS-like operating system that handles the output of and input of the standard IO application. So your standard IO application might hit printf, and the results of that ends up at the standard IO provider application, which it can then turn into something that ends up on a screen, or out of a serial port maybe. It's a very limited environment, but the idea was it was a way to take standard C code that you'd already written and port it to Palm OS so it could be run and do its thing. But not many people will have seen this feature in action because there weren't many public applications that were written this way. It was quite useful for businesses that already had a C application and they wanted at least part of it to run on their PDA without too much development effort. So how did Palm fare in the market? Well, the answer is very well. It was the most successful of the various lines of PDA that was out there, but competition did get stiffer. Psion kept developing their systems and started to make a more sophisticated version of their operating system as time went on, that eventually became known as Epoch 32 and is the thing that ended up powering most of Nokia's feature phones. Their clamshell with a keyboard design also was quite popular, but not on the same scale that the Palm Pilot was. Once Palm started to get quite successful, the pocket form factor and stylus really did appeal to a lot more people because just like a smartphone, it conveniently slips in your pocket and can be used pretty easily when you're out and about, in a way that a keyboard, not so much as you need to put the thing down on a flat surface and start typing, and it's more a put in a bag thing than put in a pocket thing. But that was not the only type of competition. There were other more handheld style devices out there. Yes, after Palm's initial success, Microsoft decided it wanted into the market and created Windows CE, probably the most benighted version of Windows I've ever seen. Honestly, I think I preferred using Microsoft Bob. So, what Microsoft did was make something that was very much like Windows with the Windows API and try and cram it in on hardware that was substantially less powerful than the PC. And this worked about as well as you think it probably did. I mean, Palm's applications were pretty rapid, easy to use, and my experience with CE is nothing it did was rapid. It also really tried to cram that desktop metaphor and the way that Windows displays and does things into a device that was pretty ill-suited for doing things that way. Now, Microsoft would license CE to just about anyone so they could build a device using it. And probably the best known of those is Compaq's iPAQ, a device that has surprisingly good hardware. Yeah, I actually really quite liked the iPAQ as a hardware device, and later on when someone did a version of Linux for it and an updated version of a desktop, yeah, that thing worked pretty well. With CE, or as it was later called Pocket PC, not so much. It did have a nice option that you could take a Compaq flash card or things that could use the Compaq flash slot, so there was a good variety of add-on hardware for the thing. And again, when I had Linux installed on one, that was pretty useful. Microsoft would later create a version of Windows CE known as Windows Mobile, which would get deployed on a number of very early smartphones. Unfortunately, it was about as stable as a Jenga tower in an earthquake. In fact, one of these early things, known as the SPV, which was created by HTC for a mobile operator called Orange, a friend of mine, Jonathan, had, and it crashed on him one too many times. They finally lost it with the darn thing, and at a Clay Pigeon event, he got them to load it into the machine and took it out with both barrels. Yet he would rather take it out with his shotgun than be forced to use it for one more minute. Apparently, just before that moment, he'd tried to answer a call and the whole thing had just crashed on him yet again, and he just couldn't take it anymore. But despite the fact that Windows CE may not have been the best operating system in the world, it was available on fancier hardware, and this really did start to eat into Palm's market share. So Palm made a shift away from their traditional hardware platform of being based around the Motorola Dragon Ball, and they shifted to ARM. The standard screen resolution also jumped up to 320 by 320 pixels, and they were all colour by default. We also had Bluetooth and Wi-Fi just built in a number of models, and we also had support for SD cards as well. And my favourite Palm devices from this era, I actually have myself a Palm Tungsten that was the last dedicated PDA device I ever used. And to be honest, this thing was kind of great. It still works to this day, and I did briefly set up HotSync, and by linking it with Evolution, I actually managed to sync down my Google Calendar to this here PDA. Frankly, it is amazing that still works. Palm also finally got out a smartphone with their Trio series of phones. It works and runs like any other Palm OS device, so it will be very familiar to all users of Palm. It does happen to have a hardware keyboard, so you can type your important text messages, and of course a cellular modem built in. Now of course these are not the first Palm OS smartphones. No, Handspring got there before Palm Inc. themselves did. The very first one is that visor I mentioned earlier, that using the springboard slot you could actually add a mobile phone add-on to it. But then in 2003, Handspring went and released an all-in-one smartphone running Palm OS, known as the Trio. Now you might be thinking, wait, isn't that the exact same name that Palm Inc. used for their one? And yes it is. You see, Handspring ended up merging back into Palm Inc. So, Handspring's line of Trio phones became Palm's line of Trio phones. Now, the Trio phones did okay, but not brilliantly. Despite the fact that they are one of the first ever smartphones, they didn't really take off as well as you think they might do. And key to that is, it still doesn't really do the mobile web particularly well. You can kind of browse the web on them, but the experience is kind of rubbish. It's basically not much better than that AdvantGo service I mentioned earlier. And why it's useful to combine the functionality of a PDA and a phone together in one device you can carry around, the whole mobile internet thing isn't really there from your mobile providers still in the same way that it would be later on when Apple's iPhone takes off and Android does. Palm also has competition from Windows CE, or now Windows Mobile, starting to appear on a number of early smartphone type devices, but also mobile phone manufacturers have started getting in on the game. So Nokia starts to launch phones that are mobile phones that are gaining PDA-like features. They got a bit of a jump start and now had an operating system called Symbian. Symbian was produced by a consortium and was a descendant of Psion's Epoch. And Nokia, up until this point, had pretty much in Europe owned the mobile market, and these feature phones flew off shelves. As mobile phone cameras had started to become a thing, and we had internet technologies like WAP. Okay, WAP was never that successful. But these feature phones really ate into the PDA market because they could do a lot of what a PDA could do, but it was also a really good phone. Whereas the early smartphones that were PDAs that had some phone features grafted into them were not great at being phones. Even the eventually hugely successful iPhone, if you tried using the original version as a phone, it was actually pretty terrible as a phone. Would it twit in with your Bluetooth car kit? No, it would not. Would it work with any other mobile phone accessories? No, it would not. This feature phone market essentially stopped smartphones, or at least the kind of ones that Palm and Microsoft were helping to produce, from really getting a foothold. It wasn't until we got the iPhone that the whole smartphone thing really took off in 2007. And I think key to the initial success of the iPhone was that thing was a pretty good mobile browser. You finally had the mobile internet and the kind of data plans to go with it from mobile phone operators that weren't going to bankrupt you for trying to look at one website. It took a number of things happening at once for that thing to become a success that had just not quite coalesced together in time for Palm to be able to do well out of this. So what happened to Palm? Well, in 2000, Palm was spun off back into its own company again, called Palm Incorporated, and had about 74% of the market share. In 2003, it finally merged back up with Handspring, but with PDA devices becoming less of a thing, and their smartphones really not taking off in the way that they'd hoped, Palm split itself into two companies, Palm One, that would do the hardware, and Palm Software, that would own the operating system and other bits. And that happened in 2003, shortly after the whole Palm Handspring merger thing. And then just to make things weird, Palm One in 2005 would buy the remaining shares of the naming rights of Palm from Palm Source and would call itself just Palm again. Palm Source would then get acquired by Access Systems, who would then subsequently sell the rights for the Palm OS source code back to Palm Inc. in December 2006, undoing basically everything that had happened in the last 3 years. By then, Palm had created a new operating system called WebOS. As an aging operating system initially designed to run on a Motorola Dragon Ball was not exactly ideal come 2009. So Palm's focus shifted entirely to making smartphones based on their new WebOS, And we got their two final phones, the Palm Pre and the Palm Pixie. Now, these devices are not really related in any way to the original Palm Pilots. They do not run the same operating system, they are not compatible in any way. It's just they sort of share a corporate history with it. And I got to use at least the Palm Pre for a little bit, and do you know what? It was fine. It wasn't great, nothing to particularly write home about. It was okay. Unfortunately, then we came to the end of the line for Palm, and it was acquired, like almost every company I talk about on this channel, by HP, who proceeded to do what HP does and basically kill it. HP did release one final WebOS device, and oh my god, was that a disaster. I'm going to leave that tale for an entirely separate video, but I don't think HP could have screwed this one up harder if they tried. Anyway, as I said, I won't go into the details of that one because I'm planning on getting on a boat in the non-too-distant future and maybe using a bicycle, which does not end well for British people and HP. If you got all the way to the end, I'd like to say thank you very much for watching. I'd also like to give a shout out to John Newcomb, GlassTTY on, well, quite a lot of the internet, as he was kind enough to donate the Palm Free to me, which I've used in this video. If you would like to see either myself or John Newcomb in person, we will both be at Retrofest, which is happening at the end of this month, May. That's the Steam Museum in Swindon. I have a link in the description below. There will also be some of my other fellow YouTubers there. In fact, with some of them, we've even started a Discord together. Oh no. And I say we, but Lee from More Fun Making It has done basically all the hard work on this one. Yes, him and the team of moderators had quite a thriving Discord going and invited a number of other YouTubers to come be part of it. So, yes, I now have a Discord server, again, invitation link in the description below, that there's a number of other very delightful YouTubers on there. If you enjoyed the video, why not press that thumbs up button that tells YouTube that, well, you enjoyed the video. There is another button in case that was not the fact, and I'll thank you for the interaction with the algorithm. If you'd really like to help the channel out, why not press that subscribe button? Because it does make a big difference to whether YouTube wants to bother telling people that the videos I've made actually exist.